In this video, we are going to take a look at a handful of common wind events, simple circulation patterns that happen all the way from the micro scale all the way up to the macro scale. We'll start off on the micro scale and look at a simple dust storm or a dust devil. Now, a dust devil is kind of a larger microscale event. But what happens is you have warm wind moving along the surface of the ground. The wind is merely just moving along, not rising, not sinking or anything. But then every once in a while it hits an obstruction. If it hits the obstruction just right, it causes it to rise and then fall again. Well, this creates an instability, and because of an instability, that air is going to want to start rising again, and as it does so, it just starts circulating upwards, creating a dust devil. Here's a good example of a simple microscale storm. Now these can actually get to be rather large, as you can see in the figure on the right. Here's another great example of a mesoscale wind. This is called the katabatic winds. What happens is you have cold air around a high pressure system. Well, high pressure pushes air outwards, and let me redraw this. So it's going clockwise around a high, pushing it outwards, and thus, since it's on top of a high mountain slope, it pushes that air from the high down the slope into lower regions. The air will heat up as it decreases in latitude or altitude, but it will not heat up enough, and eventually it will reach the valley below, but at a very cold temperature. Now, since this air is so cold, cold air likes to sink, and so in addition to just being plain wind, you have the additional sinking motion, which increases the strength of the wind, and thus sometimes katabatic winds can reach hurricane strength. Here's another example very similar to a katabatic wind. It's called a Chinook wind, or in Europe it's called a Föhn wind. Föhn wind. I'll be honest, I don't know how to speak German, and so I'm not too sure how to pronounce Föhn winds. That's all right. We'll call it a Chinook, since I'm familiar with that. Here's the idea. You have air that is, say 10 degrees Celsius. As it rises, it reaches the dew point, creates a cloud, and then cools. So as it rises, it falls at a rate of 10 degrees Celsius per kilometer, the dry adiabatic rate. But then as it continues to rise to the top of the mountain, it decreases at a rate of 6 degrees Celsius per kilometer. Remember, that's the moist adiabatic lapse rate. That is because now that the air has reached the dew point, it is completely saturated, and you are condensing water, forming a cloud. Okay, so if we go up 3 kilometers, we decrease by 10, we go from 10 to 0, then we decrease by 6, you're at -6, then -12. But now, as you go on the other side, the downwind or the leeward side of a mountain, you've left the water behind, and so it's going to rise at a rate of 10 degrees Celsius per kilometer. And it's going to go from -12 to -2 to 8 to 18, leaving very hot, dry winds on the leeward side of a mountain. So you start off with cool, moist air, and you end up with hot, dry air. This has often been called a snow eater, because if you have any snowy areas on the leeward side of the mountain, these snow patches will very quickly melt because of the heat of the Chinook wind. All right, here's another good example, a Santa Ana wind. This region of the United States here is what we call the Great Basin. When you have a high pressure system that forms over the Great Basin, you have air going clockwise and outward from a high pressure. Here at the bottom end of the Sierra Nevadas, you have canyons, regions that air can pass through. Well, when that air is funneled through the canyons, you get a very warm, dry wind, which going through the canyons increases its speed because it's funneled through a canyon. Plus, the canyons are decreasing in altitude, so it heats up even more. So very warm, very dry, and very fast. So downwind, an area like Los Angeles, you get this very hot and dry wind. Hot because it came from the desert, even hotter because it decreased in altitude. Dry because it came from the desert as well. Well, what does this do? Any vegetation in the area is completely dried up, creates fuel for fires. And so every once in a while you get a Santa Ana event and everyone in California gets very worried, and they have every right to be. Here is a satellite image of Lower California. Those are not clouds you are seeing. That is smoke, and every red point is a forest fire in the area. This is shortly after a Santa Ana wind. The wood had been completely dried out and created great fuel for fires, so forest fires were very abundant during that season. Now we're ready to talk about the monsoon. Monsoon is an Arabic word for seasonal, meaning a seasonal change. Now, seasons are going to cause the winds to change from one direction to another depending on the pressure systems, on the atmospheric circulations around, so on. The primary one, that monsoon, that when we say the monsoon, we're talking about this one that's in eastern and southern Asia. But we have monsoons all around the world, including here in North America. Let me describe the monsoon a little bit better. Remember back a few slides, we talked about the katabatic wind, a high pressure on top of the mountains, specifically the Himalayan mountains, driving wind down the slopes into the valleys. Well, that's what we have here. We have a high pressure that's driving wind from the high mountains to the lower lands of India, Indonesia, so on. All right. So this can be a katabatic wind. It doesn't have to be a katabatic wind all the time, but it can definitely produce katabatic winds. This is known as the winter monsoon. Very dry, very cold air. But then in the summer, this high pressure disappears and is replaced by a low pressure. Well, low pressure air is being pulled in counterclockwise around a low, like so, which is pulling all sorts of wet, warm, moist air from the Indian Ocean into India and the surrounding areas. Now, with the Himalayas being so large here, those winds aren't going to get very far. They're going to produce lots of clouds and produce lots of precipitation. So this region here just gets completely inundated with precipitation. How much? The city of Cherrapunji has an annual average rainfall of 425 inches. In the month of July alone, you're getting 135 inches. 1 month, they get 135 inches. Now, just for comparison, here in Daytona Beach, the highest average rainfall, monthly rainfall, is in September, which is 6.61 inches on average of rain. But the record monthly rainfall happened in September of 1979. The record is 15.20 inches. On average, Cherrapunji gets 135 inches just in 1 month, the month of July. That's average, which means there are some months where they get even more. Like I said, this monsoon is most well known in Asia, but we do have a monsoon season here in North America. Here is our monsoon season happens in the southwestern United States. As we know, Nevada, California, Arizona, southern Utah, this whole region right here is very well known for being a desert. But for a short time every year, you get a bunch of warm, humid air that is pulled up into the region, creates unusually large numbers of storms. Sorry, thought I had a picture there. Didn't have a picture this time. But they do generally create a fair number of storms in this area. It brings in some intense rainfall, intense for the desert, which can cause flash flooding and cause a lot of concerns, but also brings a lot of much needed rain at the same time.